This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, OKGrow.com, and SpaceDojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. All right, welcome back to the third talk of Crater Conf. We have Pete Corey with us. Pete runs East Fifth, which is a consulting company that helps build Meteor apps. He has a really interesting background in web security, so I found that super interesting to learn about when we were at Space Camp together. Space Camp. And he's going to talk about NoSQL injection. So without further ado, I will turn it over to Pete.
Cool. Awesome. Thanks, Josh. It's good to be here. Thanks for coming, everybody. I'm going to take my headphones off. My speaker settings are a little wonky. So yeah, today I want to talk about a little bit of security stuff. I want to talk about NoSQL injection in modern web applications. But before we do that, you probably want to know who I am. As Josh said, my name is Pete Corey, and I run a small little web dev shop called East Fifth. We mostly do Meteor development for a variety of different clients, and I also offer Meteor security assessments as a service. And so in an assessment, I'll go through your app with a fine-tooth comb, looking at your source code, doing some hands-on testing, looking for common vulnerabilities, showing you how a potential attacker would exploit those, and then how to remediate those issues as well. I also do a lot of blogging about Meteor and Meteor security. So if any of that stuff seems interesting to you, you can check out blog.eastfifth.co and see what I'm all about. So you're probably wondering, why a security talk, right? This is a developers conference, so why am I here harsh and the mellow, I think that security is really fundamental to everything we do as developers. We spend countless hours, day after day, trying to build these amazing products. We build amazing products and we try and attract all these users and potential investors, and we try and build trust with our users and investors, and we try and make the world a better place. But all of that can be completely washed away by one small vulnerability. Everything operates on this assumption of security, right? This linchpin assumption. So imagine that you have an application that has, a good number of users, happy users. Let's say that you have some type of VC backing or some kind of funding. Everything's going fantastically. You're on an upward growth trend. But then one day, an attacker comes by and he finds, a critical vulnerability in your application, and he decides to exploit it. And let's say that he's able to, cause direct damages to your company, and maybe he causes some direct damages to a few users. So in that situation, obviously you're going to lose whatever he takes from you, your company. Your users will lose whatever he takes from them. When you tell the remainder of your users what happened, which you should, their trust in your company and your brand will be severely deteriorated. Your investors' trust and faith in you will be deteriorated. If you lose investors, you potentially can't pay your payroll, which means that you potentially lose your employees. Future users of your app, the first thing they'll see when they Google your application's name is this TechCrunch article talking about, how this attacker stole, whatever they stole from you, and however they affected your users. So everything operates on this assumption of security. We're building cool things, but they have to be secure, cool things. Otherwise, what's the point, right? So what is NoSQL injection? Well, NoSQL injection is a relatively new thing because NoSQL databases are a relatively new thing. You may have heard of SQL injection. SQL injection is basically an attack against a SQL database, like a relational database that uses SQL strings as control mechanisms. So you've probably seen this XKCD comic where this kid's name is, Robert single tick parentheses semicolon drop table students. SQL injection is what happens when you take unvalidated user input and you just directly concatenate it onto a SQL string, and then you run that new SQL command in a SQL database. So the user's input, in this case, Robert single tick blah, 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 takes control of that query through that string concatenation and makes it do something that it never was originally intended to do. So in this case, by doing a search for the student's name, for example, you would inadvertently drop the entire student's database. So this was a problem for SQL databases because they use strings as control mechanisms, right? Like a SQL command would be a string. That's like select star from table blah, 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 etc. But what about NoSQL injection? NoSQL injection or NoSQL databases like MongoDB or Redis. Redis is a bad example, but MongoDB, for example, or Rethink don't use strings as control mechanisms. They use objects. So like a MongoDB query is actually an object that specifies kind of the structure and the type of data you're looking for. It's not a string. So how could a user inject something into that object to kind of take over the query? There's nothing you can inject into an object that would really alter the structure of that object, right? Well, to get a better idea of what I'm talking about, I want to give you guys a demo. I'm going to show you kind of a demo Meteor application, and I'll walk you through some NoSQL injections and talk about what you can do to exploit the application. So let me get this set up here. Okay. All right, awesome. Okay, so this demo is going to be using an application called Meteor Shop. And Meteor Shop is actually kind of an educational demo e-commerce app written by Rob Connery. And he actually has a whole Pluralsight course dedicated to building this from the ground up. It is a Meteor app using MongoDB. MongoDB is important here. Everything I'm going to talk about is specifically targeted at MongoDB. And I'm going to be picking on MongoDB quite a bit. And we'll talk about why later in the talk. But the Meteor portion of this is not important at all. I'm going to kind of gloss over quickly some of the minor details that you need to know about Meteor to understand what's going on here. But really everything I talk about applies to any stack, any framework. Meteor, vanilla Node using Express or something, Laravel, whatever else you want to use. So this is all totally applicable. The app is pretty simple for an e-commerce app. You've got your home page. This particular e-commerce app is selling like space tourism products. So you can like buy a vacation to Mars and buy some add-ons for that vacation and stuff like that. It's pretty simple. You can add items to your cart. Oops. You can update your cart and it updates. You can remove items from your cart. You can browse by vendor, so I can see all the products that Martian Armament sells. So it's all pretty straightforward. You can actually add an item to your cart and then go through with the purchase. So I've got some test data here. And this is actually wired up to a demo Stripe account, so I can actually follow through with this purchase. Let me give some fake data here. I live in Schenectady. All right, so I'm going to purchase this trip for $89,000. And that purchase was successful. And if I actually go up to my Stripe dashboard, and I refresh this page, I can see that that purchase went through for $89,000. Everything is good. This redirect's a little broken, but we don't need that for the demo. So that's kind of the happy path of the application. That's what a normal user would see. But a malicious user might see this app in a very different way, right? So they're not really interested in buying products at whole price. They want to get different things out of this application. So for example, they may want to retrieve information. We see all these products here, but maybe there are other products that are hidden or accessible only to certain users. A malicious user might want to see all the products in the system to potentially be able to buy them when they shouldn't. A malicious user may want to see information about your users, right? They may want to see what other users are using the system, what they're buying, some private information about that. Maybe they can take that information and sell it to a third party for a profit. Maybe they want to modify some information. Maybe they want to modify other users' carts, add or remove things from their cart, remove their carts altogether. Maybe they want to be jerks, prevent people from using the software. Maybe they want to change product prices, right? Maybe I don't want to pay $89,000 for this. Maybe they want to pay $2. Maybe they want to give themselves admin rights. Maybe they want to go through some kind of privilege escalation scenario where they become admins and they can modify prices at will or see user data at will. And barring all of that, if none of that works, maybe they just want to be really mean people and prevent other users, like other good users, from using this software. So they want to deny service. So these are all potential motivations that we might have as attackers of this application. But how would we actually go about doing any of those things? So we'll start kind of simply and slowly, and we'll work our way up. The first thing we want to do is get a list of all products here. So let me open up a console here. This is just a browser console. Let me increase my font size a bit. So I'm going to skim over the Meteor details. Suffice it to say, there's a thing called a publication that is basically a function that you can call from the client, and it returns data from the server to the client. So in this case, there's a products by vendor publication, and it takes a slug as an argument. So we can actually subscribe to that publication on the client. And this client has already subscribed once, and we can see all the products available to us on the client. So right now there are 3 products available, and that's these 3 right here. So there's the Honeymoon to Mars, there's the Johnny Liftoff product, and the third one is the reentry. And so we saw that it accepts this slug argument, right? You can see it right there. And slug is intended to be, so for example, in this case, oops, oh man. So in this case, slug is this string Martian-armaments. So normally, when you call this publication or subscribe to this publication, you would say products by vendor, and then you would pass in that slug. And so your subscription goes through, and once again, we can see all of the products on the client, and it's the same 3. Well, there's 4 this time because we added this Mars Mobile one. But what would happen if we passed in something besides a string here, right? So instead of this string Martian armaments, what if we did something like 2? So the subscription works. We just don't get any more products. But that's interesting. Why can we pass in a 2? We're assuming that slug will be a string, right? So basically, we want our query to look like so this is basically the Mongo query that gets created when we do this products find on this publication line. And we're not making any, we're not telling the system what slug should be. We're just assuming that it's a string. But because we're passing these messages via DDP, it can really be anything. It could be a number. It can be undefined. It can be null. It can even be an object. And that's the key that I want to show here. So what if we pass in an object to this publication? But what if we make it a very special object? What if we say we want to find all products whose vendor key matches this object? So this is a special object. We're saying we're creating an object and we're giving it a key whose name is $GTE with a value of empty string. So if we subscribe to this, and then we view all the products on the page or on the client, we suddenly see a lot more products, right? So there's only 4 on this page, so we should only have 4 here. But now we have quite a few more. So we have, a lot of products we see here, but there are some here that we haven't seen before, and that we probably shouldn't be seeing. So why do we suddenly see these? Well, it's because we passed in a special object to our query. We passed in an object that was actually a Mongo query operator. So our query looks like this. We're finding all products whose vendor slug, and this special field actually means greater to or equal to an empty string. So we're finding all products with a vendor slug that is canonically greater than an empty string, which is actually every product in the system. As I mentioned, this is a query operator. So in this case, it's the GTE query operator. There are lots of query operators in MongoDB, and they're basically just fields that have special meanings for the database. When it sees one in a query object, it will interpret it differently than just a normal field. And in this case, like I said, it finds all documents whose vendor slug is greater to or equal to an empty string. And so that's kind of the fundamental basis of NoSQL injection, right? We're not injecting strings into strings. We're injecting sub-objects into query objects. And by doing that, we can potentially modify the flow of the query and use it to, get data that we may not be able to get in a normal circumstance. And we can take this a little bit further. So the products example was a little boring, right? We probably could have found all these products through normal usage of the page. But what if we want to see other users' personal data? What if we want to see like the carts that they have and what they're buying? So we can do the same exact thing. There's a carts collection on the client, and we can see what we have right now. And we have no carts available to us. If we go ahead and add something to a cart, and then we try again. So we can see our own cart, and this is fine. Obviously we have access to our own cart, but we can't see other users' carts. And that's obviously for good reason, right? That's private data. We should not be able to access that. But there's another publication that we can, attack. There's this cart publication, right? So this takes in a key, and it finds all carts whose user key matches that passed in key. And in this system, user keys are supposed to be a secret. They're hashes, not hashes, but they're hex strings that uniquely identify a user. And they should never be exposed to the public. They're supposed to be completely secret. Only you know your key, so only you can access your cart. But again, we can just call the subscription manually. We can say meteor.subscribe. And then we don't have to we could do the GTE empty string, but we can also do another query. So we can say, find all carts whose user key is not equal to an empty string. Oops. So now if we fetch all the carts available to us again, now we have 2 carts. One of these is mine. I think this one is mine. And this one belongs to someone named Sarah Schmo. So now we have Sarah's email address, her IP address, all the items she's purchasing, notes about her cart, her cart history, things like this. We also have her user key, which is useful later. So this could potentially carry a lot of really personal information, right? This is this is a bad thing that we can get this. If we were malicious users, we could potentially take this data, farm this data, sell it to third parties who were interested in this kind of user data, things like that. Lots of bad stuff, right? We can also get these carts in a different way. So both of these previous examples we've seen have attacked find queries, right? So this was also a find query. This would have looked like db.carts.find user key, whatever. NoSQL injection isn't limited to find queries, though. We can actually attack find one queries as well. So there's a method in this application called getCart, and getCart accepts a user key, and it passes that user key into a find one. So what would happen if we call, let's grab our user key just to have a base of comparison. So if we say meteor.call getCart, and then we're going to pass in that user key. And then we're going to add a function on the end. That's an array result function. We'll log the result. All right. So getCart returns a single cart. And in this case, it returns our cart. This is our user key. And we can double check that. Let me drop this font a little bit. There we go. So we can see that this is our object. This is the item we're ordering. Everything's good. But what if we drop in a Mongo query operator again? What if we say getCart, whose user key is greater to or equal to an empty string? Okay, so in this case, we got Sarah's cart, which is probably a bad thing, right? We shouldn't be able to get other users' carts through this method. But we can see that we only got a single cart this time, not all the carts in the system. If we repeatedly do this, we'll still only get Sarah's cart because the Mongo ordering of this collection is such that this is the first document it checks, and this is the first document that matches that query, so it's the first document that's returned. And at that point, it just stops because it found one and moves on. But we can actually tweak this query a little bit to find all the carts in the system one at a time. So there's a query operator called NIN, and the documents say that it matches none of the values specified in the array. And it basically stands for not in. So we can say, give me a cart whose user key is not in this array. I'll pass in an empty array. So that gives us Sarah's cart again. But this time we're going to grab her user key, and we're going to repeat this query. So we'll say, give me a cart whose user key is not in this array, and we're going to drop in that user key we just found. And if we run this, it's going to give us the next cart in the database. In this case, it was our cart object. So we can repeatedly do this. We can grab this user key, push it back into that array, repeat the query, find the next cart, and repeatedly do this until we have all the carts in the system. You can easily write code that would do this. I have some code, but it's a little long and not that useful for a demo. Okay, so that's a lot of data we can get, right? But what if we wanted to move beyond just getting data? What if we wanted to modify data in some way? Well, the same things apply, right? We can exploit find queries. We can exploit find one queries. We can also exploit remove queries. There's a method in this app called empty cart. So empty cart just does a Mongo remove on all carts whose user key matches the provided user key. So again, we can just come in here and we can say meteor.call empty cart whose user key is greater to or equal to an empty string. And boom, suddenly it removed my cart. But we can also see that it removed all the carts in the system. So if we do a quick fetch, Sarah's cart's gone too now. So I can easily create a quick method that would call this function or call this meteor method, right? And then timeout, call the method again. So if I run that, that's basically setting up a function that will immediately remove all the carts in the system. and then in 1,000 seconds call itself again, remove all the carts in the system, call itself again, remove all the carts in the system, infinitely, as long as this browser tab is open. So that effectively will remove everyone's cart every second, rendering the app pretty much completely useless for all users. So if I was a truly evil user, I could do that, but we're not evil, so we won't do that. So what if we wanted to not really wreak havoc on other users? What if we wanted to do something that would benefit us, right? So what if I wanted a jetpack, right? I wanted a liftoff rocket suit, but I certainly don't want to pay $89,000. That's a little extreme. Well, let's play with this a little bit. So let's first grab our cart. So we know that our cart is available to us. We can see it right here. This is our cart. So let me go ahead and grab this. Then let's look at cart. So if we look at the cart, we see that there's a few cool fields. There's this total field. Now I wonder what would happen if we change that field. And I won't get into this now, but I've noticed that whenever I modify anything on this cart, it calls a Meteor method called saveCart, and it passes this cart object in as an argument. So I wonder what would happen if, let me resave this. I wonder what would happen if I set total equal to some other value, and then I call saveCart with that new cart object. Oh. All right, let me redo that. There we go. Okay, so let's set the total on our cart to some value and then save that cart. So nothing happened. And that's fine. As a black box, attacker, sometimes things don't happen. So let's dig into what exactly is going on. If we re-get our cart, we can see that the total didn't change. So maybe the total is actually affected by the products that we're buying. So what if I come into this first product, this liftoff rocket suit, and I change its price? So if I say cart items, let's say I set the price to about $13, and then I can go ahead and save my cart. Well, okay, now the price is $13.37. Will this actually hold through checkout? So let me try and buy this rocket suit. I can pay now. Let me enter some dummy data. Okay, fingers crossed, and there we go. So the purchase went through. Let's see how much it charged me. Yeah, okay, I think it's in there. Yeah, so originally we had a balance of $89,333, and now we can see that that $13 charge was added on. So someone was able to purchase a rocket suit for $13, which is a very, very big loss for your space tourism business. And while this isn't necessarily SQL injection or NoSQL injection, we didn't modify the query in any way, it certainly feels very similar, right? So there's a denormalization issue going on here. Instead of storing product IDs and pulling products to fetch their actual price from the database on the server, we were trusting user input. We were trusting that the product that was denormalized into this cart object was an actual valid product, which in a way is like the fundamental issue behind NoSQL injection, right? You're trusting user input, which is oftentimes a pretty big mistake. So let's move on to some other types of attacks. So let's say nothing that we've previously tried worked. We couldn't get any data. We couldn't modify prices. We couldn't delete carts. Let's say we wanted to try and become an admin. And digging through the client-side source of this app, I found out that there's an isAdmin flag on the user document that determines if you are or are not an admin. And if I look at, well, let me first sign up. So create account. Okay, so now I have an account. If I look at my user document, again, this is kind of Meteor specific, but don't worry about this. This is applicable to any framework. If I look at my user document, I have no is_user flag or is_admin flag, which means that I'm not an admin. But I've also noticed that there's a method to update my profile or my user account. I can reach that through my profile page, and it's supposed to let you update fields in your profile object. So I can usually do things like I can call update user. And I can pass in an update operator here. So I can say set profile.name, and I can set it to my name. And if I look at my user document again, and I go into the profile object, I can see that my name was set to Pete. So that's cool. But what if I know all of that as an attacker? Well, the first thing I'm going to try and do is set my is_admin flag to true, right? But we get an error. It says that we're not allowed to do that. So maybe this system is checking for direct sets against this is_admin field. So maybe if it sees that your update has a $set and it's trying to directly set is_admin, it'll throw an exception. And that's fine, because we know as attackers there are lots of different ways to modify data in MongoDB. That is the wrong tab. So in addition to set, you can do all kinds of things like inc, you can do add to set, you can do push, you can do pull, you can do XOR. To keep it simple, let's just do a simple inc. So we're going to increment the is_admin field by 1. And if we do this, suddenly this little admin button pops up, which indicates that we have given ourselves admin permissions in the system, which means that the security around the update user method is not correct because it wasn't correctly predicting all of the ways in which you can update your account or directly affect the is_admin flag. So let's undo this. Let's say that the application owner got a little more smart and they decided that normal users can't do any direct modifications to the is_admin flag. So the code will basically look for any operator in this position, so increment, set, push, add to set, whatever you want, and it will see if you're trying to operate on this is_admin flag, and if you are, it will fail. So there are still ways to get around that as an attacker. So earlier we saw that we can update our profile object in any way that we wanted. So we can set our profile.name. What if we set our profile.name to true? And then we set, what if we rename our profile, profile name, and we'll rename this field into is_admin. So rename is a valid Mongo update operator, and it basically takes the value in this field, the profile name field, and it dumps it in this target field. And if we try this, suddenly we have admin rights again. So if we look at our Meteor user or our user document, we can see that our profile name is no longer there. And I should have removed those. And now we have this is_admin flag set to true. So the security around directly setting the is_admin flag wasn't enough, right? Because we can indirectly set that is_admin flag to true with a rename operator. So let's say that none of that worked at all. So we couldn't get access to any information. We couldn't update any information. We couldn't give ourselves admin rights. Nothing has worked. And as an attacker, we're getting very angry. Let's say, so we decide that we want to basically deny access of all other users to this application. We've seen earlier that if we could update carts, we could just repeatedly remove them. But that's not that big of a deal, is it? If we can't update carts, we can't really do anything there. There is a publication in this app called vendors, which takes just a plain query object and dumps it directly into a MongoDB find query. And so we can use this to pass in a where query. So we can say Meteor.subscribe vendors, and we can say where. And where is an especially powerful query operator, and it basically lets you do some type of JavaScript for each document in the collection, and you can actually pass in a JavaScript string that will be evaluated on the database itself. And if that JavaScript string evaluates to true, that document will be included in your result set. So you can actually say like this.slug equals Martian whatever. I think you would say return. And so if the document slug matches this string, it would return that document as part of the result set. But the important part here is that this string is executed as JavaScript on the database instance. And it's any arbitrary V8 JavaScript, which means that we can run any JavaScript we want on the database. So what would happen if we run a piece of JavaScript that looks something like d equals new date, do c equals new date, while c minus d is less than 10,000. So this is a loop, and basically it creates a new date and then tightly loops, creating a new date every time it runs, and then it will loop for up to 10 seconds, basically until that new date created in the loop is 10 seconds or more older than the first date. And this JavaScript is executed once for every document in the collection. So in this case, we have 3 vendors. So when we run this, it's going to basically peg the CPU at 100% for 10 seconds for each document. So that's 30 seconds total. And because the CPU is pegged, no more queries can be processed during that time. So if we run this and then refresh the page, it's going to sit on this page for 30 seconds. And that's because, like I said, it's busy processing that loop in the background, those 3 loops in the background. And the thing is, the scary piece of this is that this 10,000 right here, this 10-second delay, is completely arbitrary, right? I was being nice by including that. A true malicious user may not include that timeout. They may just have this loop indefinitely. And in that case, the only way to recover your app is to either go in and kill that query manually or restart your database. So this is kind of a heavy-handed approach to DOSing an app. And it really only shows itself when you can expose like a where query in your application. So that is basically the demo. Hopefully that showed you some of the possible dangers of NoSQL injection when you're completely unprotected from it. So how do we fix all these issues, right? So I just went through like a huge laundry list of potential vulnerabilities and how it could totally destroy your app and all this trust with your users, but how do you actually fix these things? Well, the good news is that fixing NoSQL injection is actually incredibly easy. All you have to do is make assertions on what your data should look like, so what your user-provided data should look like. So if you remember back to the first example, we subscribed to this products by vendor publication, and we passed in a slug. And the first thing we saw was that the application always assumes that slug is a string, right? And we ran into trouble because the malicious user passed in an object instead of a string. But what if our code had some kind of check? So it said, if slug isn't a string, throw exception. So that would basically catch all possible SQL injection, right? We couldn't inject an object. That object wouldn't become part of the query object. We could only ever pass in strings, which we can't escape out of in any meaningful way to alter the query object. So there would be no issue there. So if we only have slugs that are strings, there is no issue. And in the context of a Meteor app, there's a cool little library called check, which does that exact thing. So in this case, I would have said check slug string. And now if a user tried to pass in an object, they would have received an exception, and it would have said expected string, but I got an object. So that's the basic idea behind making assertions and what your data should look like. And it's not only applicable to Meteor, right? This is applicable to whatever framework you want to use. You don't have to use check. The basic idea is that you need to know what the data provided by your user will look like, and then make sure it actually looks like that. So if you're expecting a string, throw an exception if you get something besides a string. If you're expecting an object with an ID field that's a string, make sure that what you get from the user is an object that has an ID field, and make sure that that ID field is a string. It's really that simple. Once you know what your users are passing you, you can deal with it safely. And that's actually becoming more and more of an issue in modern web applications, because with Meteor, for example, we have DDP. And over DDP, you can pass numbers, you can pass strings, you can pass undefined, null, you can pass objects. If you have any customly defined types using eJSON, you can pass those custom types. With a Node app using query string or something, QS, you can even pass in objects through a URL, right? So more and more, as we get all these helpful middlewares around our apps, it becomes less and less clear what the type is that a user is providing us, like what the type of their data is. So it's important to be explicit and make these assertions. And if you do this, and if you do it well and you do it thoroughly, your application should be free of NoSQL injection. So the demo was based on MongoDB, and I've been picking quite a bit on MongoDB. And there are a couple of reasons for that. This table is pulled from, I think, dbengines.org or .net, and it's basically like a global ranking of databases. And as you can see, MongoDB here is number 4 in popularity. Above it, Oracle, MySQL, and SQL Server are all SQL relational databases. Mongo is the first and most popular NoSQL database. And aside from Cassandra in 8 and Redis at 10, it's the only database or NoSQL database on this list. Further down the list are things like RethinkDB and CouchDB. But in terms of popularity, Mongo currently is number 1 by kind of a long shot. And Mongo has an interesting design decision that I haven't seen in any other NoSQL database. As you saw, it intermixes query operators with user-provided data. So when you construct a query, you may have, a field, and then in the place of a value, it can either be just a primitive value, or it can be some kind of query operator object. And by mixing data and control structures like that, it really opens itself up for this kind of SQL or NoSQL injection. And I feel like that sets it apart from other NoSQL databases. In particular, Redis isn't really susceptible to this issue because, on the whole, Redis is just a lot simpler of a solution, right? It's a key value store. So when you're operating on Redis, you're either getting or setting keys. You may be getting or setting hashed keys, things like that. But you only ever have one operation. You don't really add subqueries or modify that operation in complex ways. You just have your operation followed by data. And that data can't really be escaped. And if you're constructing your queries properly, NoSQL injection isn't really an issue. CouchDB is an older NoSQL database. It's like Redis in that it's a kind of a key value store. except it opens up the door for more complicated queries through what it calls views, which are basically just like pre-programmed filters and aggregations that the developer creates ahead of time. And by creating those ahead of time, you don't give the end user the option of injecting new control structures into those views. They're already set in stone. The only thing a user provides is data, and that data will never affect the flow of the query. Rethink is a cool new database that's gaining a lot of popularity lately. And in the same way that CouchDB set its queries up in stone ahead of time, Redis does the same thing using a cool chained API. So you start every query with your table, and then you filter down by chaining filter functions. And again, you can't alter the flow of those queries. They're set in stone at compile time. The only thing a user can ever do is provide data, and that data will never be given the opportunity of changing the flow of the query or taking over the query. And that idea in general is kind of what has made ORM successful in a way, right? So an ORM is basically just a library wrapping around your database query. So by chaining together these filters and update operations, you can create your query object without ever actually dealing with the object itself. Laravel, if you've used that, a PHP framework, has a MongoDB wrapper, a wrapper around, well, it's an eloquent ORM wrapper around MongoDB. And it actually solves the NoSQL injection problem for Laravel. You build all your queries with this ORM, and it creates this nicely formatted MongoDB query object. And because you use the ORM, your queries are set in stone. Users can't inject additional query operators into the query. So it kind of avoids the entire issue of a user hijacking your query object from you. But bringing it back to Mongo, that I feel like those two reasons, the popularity of Mongo and that interesting design decision of intermixing control structures and user-provided data, I feel like those set it apart when it comes to NoSQL injection. And I feel like if you're using Mongo, as long as you're aware and as long as you're thorough in your checking of user data, you'll be fine. It's just something to be aware of and something to watch out for. So thanks, guys. I showed a couple links here. The first is to Meteor Shop, the Rob Connery app that I talked about. And the second link is to a Meteor plugin or package that I've written called Check Checker. And Check Checker just does some basic static analysis of your Meteor application and makes sure that all of your publications and methods are doing proper checking of user-provided arguments. And if you're not checking anything, it will give you like a linter style warning in the server logs. So I'll hand it back over to Josh. Josh, are there any questions?
Indeed, yes. Many questions. So
cool.
We'll get to, we can close that one. We'll get to Ramsey's question first. Our next speaker had a question. Does using GraphQL with Mongo mean we don't have to worry about any of this ever again? Ever.
Yeah. So embarrassing. I haven't looked into GraphQL that much yet. I feel like it might. I really can't speak objectively here, but because you're kind of defining the structure of the data you want on the client, right, and doing the actual querying on the server, you should have a lot more control over what that query looks like. I don't want to, talk about stuff I don't know about, but I have high hopes for GraphQL. Maybe I'll look into it this weekend.
Yeah, just get it done. Come back to us, Pete. Give us an answer. All right. I know we've talked about this before, but are there any good ways to find available method calls or subscription calls that a client could make without access to the server-side code in Meteor? So like sniffing around.
Yeah, definitely. Yeah, there are a few ways. I didn't talk about that in this demo because I wanted it to be kind of Meteor agnostic. But so if you're on a Meteor app, you can open up your console and you can look in the Meteor object. There's a connection object. And if you look in connection._method handlers, That'll show you all of the client-side method handlers, and you can view the source of those by saying like connection.methodhandlers.whatever method.toString. Those are methods that they've made public to the client. You can also dig through the source looking for just meteor.calls. And sometimes you'll find methods that they defined on the server, so they're not visible to the client, but you can still see them being called, so you know they exist, right? So you can kind of peruse out the arguments and figure out what to call them with, and you can tamper with them that way. You can also just watch the GDP wire to see what's being called.
Yeah. Okay. Good answer. Are there any other security concerns we should look out for besides NoSQL injection when it comes to a Meteor app specifically? I feel like you covered a few, actually.
Yeah, it was mostly NoSQL. NoSQL is for sure the biggest one. I mean, there's always, the old monster of XSS. That's not really that big of a deal in Meteor, though. Over-publishing is a big one, but that kind of comes back to NoSQL injection. I mean, you should check out my blog. I talk a lot about different types of vulnerabilities.
Indeed. All
Josh,
right.
do you have any?
Huh? No, I don't have.
Do you have any?
I have blog posts. Is that what you mean? Okay. So this is a good one. How did you get into security? Was something hacked that got you interested?
So I've always kind of been interested in it. My first job in college was actually as a penetration tester for a company called Cigital. And that was like, to this day, one of the coolest jobs I've ever had. So basically, I would like run automated scans on web apps, and I would verify the results and look through the app myself and kind of try some hands-on stuff, and then show the application owner, your app is vulnerable here, here, and here, and you should fix it by doing this. And yeah, I mean, I've always loved it. It's really fun. Like, it's almost like a little like a puzzle you're trying to solve.
Yeah, that's awesome. All right. Okay. We'll totally do this one, maybe. Do you think insecure Meteor package should exist? Do you think the default Meteor should create a boiler app complete with secure methods?
Yeah, so there's been a lot of talk about that, right?
Yeah. I've definitely
I think
lobbied to have it removed.
I think it would be a good idea to make it debug only by default.
Exactly.
And if you want the insecure functionality, like you can go and add, I think you've talked about this a lot, like you can add a package that's, insecure, explicitly allow insecure in production, like Meteor add insecure production or something like that.
Yeah. So, I totally tried to figure out how to market debug only, but like I don't know what exactly they've got going on with insecure, but it's like I got like 4 packages deep and couldn't find the actual code. And just gave
weird
up.
Placeholder packages, I've noticed.
Yes, they do. And insecure is one of those. Like it seems to trigger an if statement way lower down somewhere in another package. So yeah, I totally think they should remove that or make it debug only. And I also think, same thing with auto publish. I don't really see in reality.
They have their value, right, for like prototyping, but you really don't want to go to prod with insecure or auto publish on your app. Yeah. Like bottom line, don't.
Yep.
Don't ever.
Yep. And people have totally. Like I've seen like professional level coding shops that have let people launch with insecure still left in there.
Yeah.
All right. All right, one more. We'll do one more. Is there a Meteor ORM like library that protects us from Mongo's issues like the Laravel one? So have you used any of the other ORM options out there?
Not for Meteor, no. There's like
Astronomer.
Astronomer, yeah. I haven't used Astronomer, but that seems like the kind of prevailing choice right now if you want to get that kind of thing in your app.
Yeah.
But no, I haven't used any.
I haven't used it either, to be honest. All right. So we've got about 5 minutes before the next talk starts. So we'll take a quick break and then we'll get started with that talk again. And I just want to say thanks, Pete, for coming on and doing this talk. It was awesome.
Yeah, it was a lot of fun. If you guys have any questions, let me know. I'm on Twitter.
Yeah.
Whatever.
Definitely. Or the Slack chat
Slack.
if you're in there.
Yeah.
Yes. I'm going to keep this Slack room running forever. I think it'll be awesome. And then also, I'll put a link to the YouTube video in the chat as well. You did a talk that was similar but slightly different at Space Camp too. So
yeah, and one thing, CryptoQuick said simple schema, and yes, simple schema for the win. That protects you from a lot of stuff. So
yeah. He even suggested you could use schema as an input, a way to check your inputs.
Yeah, with check, you just say check variable, simple schema, whatever. You're good.
Yep. Yeah, awesome. All right. Thanks, guys. We'll see you in the next video. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.